So glad you stopped by. So anyway, as I was saying, Robert, Robbie, Bobby, Bob. Let's go with that. Try to make these videos somewhat entertaining, for the students. Really do, while at the same time trying to get information in there they need in order to learn the math and be able to do the assignments.
Oh, that's really cool. I appreciate the kind of complexity of it.
So back when you were in high school, you were a big fan of math and math class, right?
Sure.
Yeah, that's cool, man. I was talking with our principal, Dr. Guthrie, this week. You did know that he graduated this month with his doctorate, right?
Yeah, he's becoming a better guy.
Yeah, we were talking about, we've got all these lessons out there, all these great lessons. And, some students are they're skipping the videos and just going straight to the assignments and trying to do the assignments without ever learning the lesson. That wasn't you in school, right? You were one of the ones that paid attention to the lesson, right?
Sure.
Yeah, some of the students, they're really sharp in math, and they don't have a lot of problem doing that. If there's something they don't understand, they look it up on the internet, and they seem to do okay. But there's a lot of these students that, man, they have no idea what's going on. You can tell by what they make no sense with the answers they put on there. They really need to be watching the video.
Are we promoting a movie?
Oh, sorry. Where was I?
Your foot's starting to jump a little bit. You better get to your next question.
Right. So we're just about to wrap up the school year, and
What are we doing?
oh man, it's late. I got to do a lesson. I got students waiting on me. I'm sorry. I got to run.
Bye.
Oh, cue my intro. I'm coming. All right. Hey, I'm here. Hold on. I'm here. Sorry. I got a little distracted, lost track of time just a little bit. Glad you waited on me. So, hey, let's try that. Hi there. How you been? Yeah, I got a little tied up. Had some guests over. Let's see. School, last week of school. Man, we are wrapping it up. This is it. This is going to be our last math lesson. Wednesday, we're going to have just something fun to do. I want you to hop on Wednesday, take a look at the video of Miss Smith and I, and then give you a chance just to do something fun that we can see, and hopefully get a chance to see what some of your other classmates are up to, if this works right. So we'll see how that goes. But we are going to wrap up today with something you're going to use next year in geometry all the time. I can't tell you how many times that we used the Pythagorean theorem this year in geometry. It seems like every month you have a situation where it's applicable. Doesn't matter what unit we're studying, at some point you run into the Pythagorean theorem. So we need a good refresher course in the Pythagorean theorem before we get into geometry next year. So we're going to wrap that up this year on that right there. So let me change screens, get onto that. The right thing. Okay. That's not it. Hold on. Wait. Let me see. Hey, that looks a lot better. Okay. All right. Pythagorean theorem. Okay. Important things to remember with the Pythagorean theorem. Okay. Let me make sure we're all in focus. All right. Everybody fuzzed in. Oop. All right. With the Pythagorean theorem. The Pythagorean theorem only works with a right triangle. A triangle that has a 90-degree angle. If it's not a 90-degree angle triangle, if it's not a right triangle, the Pythagorean theorem doesn't apply. Doesn't matter. It doesn't work. It's not for that triangle. It's only for triangles that have a 90-degree angle. So, if you have a right triangle, a squared plus b squared equals c squared. C is always the longest side of a triangle, which we call the hypotenuse, right? The hypotenuse. So the longest side of a right triangle is the hypotenuse, the hippopotamus. No, the hypotenuse. The hippopotamus. It's always the side opposite the right angle. So if the right angle is right here, it's the side that's opposite away from that. Just like up here, Right triangle, the opposite. That's going to be the hypotenuse over there. So the longest side, if you just remember it's the longest side, you'll be fine. It's the longest side. So AC is the hypotenuse, right here. A to C is the hypotenuse. So the Pythagorean theorem. Let's look at an example of it at work. So this can be used to find the length of a side, and it can, any side. If you have two sides on a right triangle, doesn't matter which two sides you have, you can find the third one with the Pythagorean theorem. So in this case, we have A and B equal to 3 and 4, and we do not know what the hypotenuse is. Okay, this is the simplest use of it. Trying to find C. You have A and B, you're trying to find C. So take your formula. A squared plus B squared equals C squared. Let's zoom that in even closer. Let's get right down to it here, right? All right, A squared plus B squared equals C squared. We're going to take the 3 and the 4 and put them in for A and B. Does it matter which is which? No. The only one that matters is C. C has to be the longest side. It has to be on the side of the equal sign by itself. A and B are interchangeable. You can name whichever one A and whichever one B you want. Traditionally, A is usually the shorter side. Doesn't have to be. A and B interchangeable. So 3 squared plus 4 squared equals C squared. So 3 times 3 is 9. 4 times 4 is 16. 9 plus 16 equals C squared. So 25 equals C squared. So is this 25? No, that's C squared. Squared. That is what C times C equals. C times C equals 25. So since C times C equals 25, it must be 5. Or negative 5. But since we're talking about a length, we can't have a length of negative 5. We throw out the negatives. We only use the positive numbers with the Pythagorean theorem. So, in this case, C equals 5. We know that that side of the triangle is 5 long. So 3, 4, and 5. Does it always work out so nicely? No, most of the time triangles end up with a decimal. Just because. But there are certain triangles, like the 3, 4, 5, that are called Pythagorean triples because they're all whole numbers that work with the Pythagorean theorem. This is a Pythagorean triple. All right, little bonus there in the Pythagorean triple. Let's look at just a couple of practice problems. We're not going to take a lot of time today. Like I say, I'm going to give you a little bit of problems similar to work for your lesson day. Nothing long, short. Finish the year. Let's get done. Let's have some summer, right? Have some summer. Of course, Wednesday we'll have an assignment. Thursday, Friday, Tuesday of next week is supposed to be finals, but no finals. Instead, there's a competition between us and those other guys at the other high school over there who shall remain nameless, right? So, things are worth points. Should have the email by now. Read your email. Look at how many points things are worth. Go do something. Let's get some points and let's go west, right? Go west. Let's go beat those other guys. All right, solve for the missing side. We have a 3. We have a 7. We do not know the other side. This must be C, all right? Because it's the longest side. So 3 squared plus 7 squared equals C squared. So far, so good. 3 times 3 is 9. 7 times 7 is 49 equals C squared. 9 plus 49 is 58 equals C squared. So C does not equal 58. It equals whatever multiplies by itself to get 58. Not a whole number. Not a whole number. C equals the square root of 58, which our calculator, if you like a decimal, the square root of 58 is about 7.6. We'll round it to 2 decimals. 7.62. 7.62. 7.62 is a correct answer. Another correct answer is the square root of 58. That's actually more correct because it's not rounded. It's the actual, all those decimals and everything that's not seen on the calculator. So either one of these would be a correct answer for the hypotenuse. 7.62, we like to do that just because we have some idea of how long that is. Square root of 58, I really don't know how long that is, right? Double check yourself, please. Is this answer longer than the other two sides? Yes, it is. Okay. If we come up with 6.62, we'd have to go somewhere where we made a mistake because it's supposed to be the longest side, and that would make it shorter than the 7. Double check yourself. All right, let's look at another one. Solve for the missing side. We're like, oh, wait a minute. There's kind of up there. What side are we missing? Is that the A, the B, or the C? This is the right triangle. This is the side opposite. This is also the longest side. Again, we are missing C. So don't let that fool you. 7 squared plus 10 squared equals C squared. 7 times 7 is 49. 10 times 10 is 100. So 149 is C squared. So C equals the square root of 149, or square root of 149, 12.21. We'll take that to the second decimal. The 6 makes it round up, so 12.21. So there's what is that longer? 12, 10, 7. Yep, that's the longest, so we're probably okay. All right, let's look at this one down here. Make sure we're in focus. Maybe my glasses. Oh, there we go. All right. 7.4, 3.6. We're missing the side. Is that the C? No. Look, that is the C over there. That's across from there. That's the longest side over there. So, very important to set your equation up correctly. Again, we can call this A or B. Doesn't matter. Since it's the shortest side, we'll go ahead and call it A. So 3.6 squared plus B squared. Again, we don't know what B is. That's what we're trying to find. What is B? Equals 7.4 squared. When I see students miss this, it's usually because they put all their numbers over here and they put B over there. It doesn't work that way. The longest side will equal the other two sides added together, squared. You can't do it the other way. If the longest side is not by itself, it'll never work. You won't get the right answer. So set it up correctly. A, B, C. Make sure you put them in the right place. All right, 3.6 squared. We're going to use our calculator for sure on this one, right? 3.6 squared is 12.96. So 12.96 plus B squared equals 7.4 squared. 7.4 squared, there's a little squared button, is 54.76. All right, where do we go from there? We're trying to get B by itself. We're just trying to solve what B is. So we got to subtract 12.96 from both sides because there's no B there. It's just a number. And that means B squared equals 54.76 minus 12.96. So 54.76 minus 12.96. 41.8. 41.8. So B equals the square root of 41.8, or, let's figure out what that is. The square root of 41.8 is 6.47. 6.47. All right, let's check ourselves. 6.47. The hypotenuse is 7.4. The 7.4 should be the longest side. Since ours is less than that, okay, we got a pretty good chance that maybe we've done it correctly. All right. One last problem. This is it, guys. This is where we're wrapping it up. Because I'm going to give you a problem like this. Gave you all three sides. Is this a right triangle? Well, I don't have a protractor to measure to see if it's 90 degrees. We don't have to. If it's a right triangle, then A squared plus B squared will equal C squared. If it's not a right triangle, that won't work. A squared plus B squared will equal something different than C squared. So we just test it. So we take 5 squared plus 12 squared. And C, does it equal 13 squared? So 5 times 5, 25, plus 12 times 12, 144. Hopefully that's one of those you have memorized. What is 13 times 13? Nice to have that memorized. It's 169. double check that for you. 13 squared, 169. So 25 plus 144. 20 plus 40 is 6. 5 plus 4 is 9. 169. Since that is a true statement, 169 does equal 169. This is a right triangle. Gotta make sure we answer the question. The question was, is it a right triangle? Not, can you do the math down here? We just have to do the math to make sure we answer the question. That's always important in math. When you do any of this work, make sure you're answering the question that was asked. We make that mistake sometimes. We get off working this formula and we get through the formula and say, hey, we're done, but we never answered the question. Oh, gosh. How was this year? Crazy, huh? Certainly ended up a little crazy. Didn't expect this when we started. But anyway, Wednesday, be looking for that assignment and say it's going to be just a short, it'll be a fun thing. It's not going to be a bunch of math like we're doing today. We're done with the math. This was our last math. Wednesday, just be something fun. Grades have to be done end of the week. This is it. We're going to have everything. So if there's any makeup work you are still trying to get done, some of these online assignments, get them done now, because the end of the week, it'd be too late. So anyway, maybe I'll see some of you guys next year in my geometry class. Don't know. But if not, you know where I'm at. See me in the hallway. Say hi. Do something. But anyway, until then, do work you can be proud of. We'll see you later.